Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss sequence and series. In this chapter, we are going to discuss the problems in the exercise 9.2, page number 185 in the textbook. In the previous class, we have discussed the concepts of this exercise and we have already completed 7 questions so far. Okay, my children, I hope you have understood the concepts of this exercise and you have learnt the sums in this exercise from question number 1 to question number 7 well. Haven't you, my dear children? Right. Now, come to the question number 8. Are you ready to listen the class? Right. If the sum of n terms of an AP arithmetic progression is Pn plus Qn square, where P and Q are constants. Find the common difference. Understood this question, my children? Here, the sum of n terms of an arithmetic progression is given. We have to find the common difference. How do you find the common difference, my children? Second term minus first term, or third term minus second term, or fourth term minus third term. Then we get the common difference in the arithmetic progression. Yes or no, my children? Right. Here we are given that sum of n terms are n AP, that is equal to Sn. The sum of the n terms of n AP is given as Sn. Pn plus Qn square. Okay, my children. Right. Now, Tn. What does this notation denote? Tn, nth term of that arithmetic progression. Nth term of the arithmetic progression can be defined as Sn minus 1. Sum of the n terms minus sum of n minus 1 terms. Then we get to nth term of arithmetic progression. Okay, my children. Right. What is Sn here? Pn plus Qn square. Okay, my children. Minus Sn minus 1 means in this expression, let us substitute n minus 1. Okay, my children. P into n minus 1 plus Q into n minus 1 whole square. Understood? This is second term, my children. Sn minus 1. So, in this expression, we are substituting n minus 1 in the place of n. Then we got this second part. Understood this point, my children? Right. Now let us simplify this one. Pn plus Qn square minus Pn minus P into n minus 1 minus Q into, let us expand this one. What do you get here? N square minus 2n plus 1. A minus B whole square. Okay, my children? Right. That is equal to Pn plus Qn square. Let us use the distributive property. Minus Pn plus P. Understood these two terms, my children? Plus P. Now let us use here also distributive property. Minus Qn square plus 2nq minus q. Okay, my children? Understood this step? Right. Now let us simplify the terms. Here plus Pn minus Pn gets cancelled. Plus Qn square minus Qn square gets cancelled. Then what will you get here? P minus Q, P minus Q plus 2nq. Okay, my children? This is nth term of this arithmetic progression. Understood this point, my children? Right. Now let us find T1. Put n is equal to 1, 2, 3, 4 and so on. Then we get to first term in Tn. In Tn, let us substitute n is equal to 1. Then we get the first term of arithmetic progression. if you substitute n is equal to 2, we get second term of this arithmetic progression. Yes or no, my children? Right. So therefore T1 is equal to P minus Q plus 2 into 1 into Q. We are substituting n is equal to 1. Understood this step, my children? Now let us simplify. P minus Q plus 2Q. Now let us simplify. P plus Q. So this is the first term of this arithmetic progression. Okay, my children, understood this one. First term. We got first term. Let us find the second term. Put n is equal to 2. What will you get? P minus Q plus 2 into 2Q. Yes or no, my children? P minus Q plus 2 into n means here 2. So 2 into 2 into Q. Okay, my children, let us simplify these terms. P minus Q plus 4Q. Then what will get after simplification? P plus 3Q. Understood this point, my children? Understood this step? T3. Then what will you get? P minus Q plus 2 into 3 into Q. Understood this step, my children? P minus Q plus 6Q. After simplification, what will you get? P plus 5Q. Yes or no, my children? These are enough. Actually, first two terms are enough to find the common difference of this arithmetic progression. Okay, my children. Therefore, common difference D is equal to T2 minus T1, second term minus first term. Do you remember this point, my children? Right. That is equal to, what is T2 here? P plus 3Q minus P plus Q. Understood this step, my children? Now let us simplify. P plus 3Q minus P minus Q. Okay, my children, understood this one? Plus minus P gets cancelled. 2, 3Q minus 2. What is the common difference of this arithmetic progression? 2Q. Understood, my children? Right. Now come to the question number 10. Okay, my children. Here I am not explaining question number 9 because it is the same as that of example 6. Example 6. Please refer the example 6 to solve the question number 9. If you have any doubts, ask your doubts and get your doubts clarified. That is why I am not explaining question number 9. Okay, my children, please refer example 6 to solve the question number 9. Okay, my children, right. If the sum of first p terms of an arithmetic progression is equal to the sum of the first q terms, then find the sum of the first p plus q terms. Understood this point, my children? Here, sum of p terms of an arithmetic progression is equal to the sum of the first q terms of that arithmetic progression. In this case, we have to find the sum of the first p plus q terms. Understood this point, my children? Understood this question? Right. Now come to the solution part. Let us assume that A be the first term. Let us consider A be the first term, A be the first term, A be the first term, and D be the common difference, let us assume that A be the first term and D be the common difference of an arithmetic progression. Okay, my children. So for this arithmetic progression, sum of the first terms. Okay, my children. Sum of n terms. We know that sum of the first n terms. Sum of the first n terms an arithmetic progression, that is denoted by Sn. This Sn. Okay, my dear children. Here n is subscript. Okay, my dear children. Sn is equal to n by 2 into 2a plus n minus 1 into d. Do you remember this formula, my dear children? Sum of the first n terms of an arithmetic progression. Here what is given? Sum of the first p terms is equal to sum of the first q terms. Yes or no, my dear children? So given Sp is equal to Sq. I wrote this sentence in the form of an equation. Sp is equal to Sq, means sum of the first p terms of the arithmetic progression is equal to the sum of the first q terms of the arithmetic progression. Okay, my children, understood this step? Right. Sp, in the place of n, write p. So p by 2 into 2a plus p minus 1 into d is equal to q by 2 2a plus q minus 1 into d. Understood this step, my children? Right. Here 2 gets cancelled. Let us multiply distributive property. 2ap plus p into p minus 1 into d is equal to 2aq plus q into q minus 1 into d. Okay, my children? Understood this step? Right. Now let us write the a terms this side. So 2ap minus 2aq is equal to, now let us write this d term that side, q into q minus 1 into d plus, if we are transposing this term to that side, minus p into p minus 1 into d. Okay, my children? Understood this one? Right. Now let us take common factor. 2a is common factor. Then we get here p minus q. Now let us multiply, or let us take common factor. Here d is a common factor. Then what will q into q minus 1? I am writing directly q square minus q minus p square plus p. Okay, my children. After taking the common factor, after taking it out, then we get q into q minus 1. I used here distributive property, then we get these two terms. After that, here these two, multiply these two, minus p square plus p. Understood this point, my children? Right. 2a into p minus q is equal to d into, here let us take common factor, minus d. Okay, then what will get? P square minus q square. Okay, my children, minus of p plus p minus q, otherwise p plus q, minus p plus q. I have taken minus common from these four terms. I have taken minus common, then p square minus q square. Okay, my children, minus p plus q. Understood this step, my children? Right. 2a into p minus q is equal to minus d into a square minus b square. How can you write? A plus b into a minus b by using the algebraic identity I wrote here. Here I am taking minus common, then we get to p minus q. Okay, my children, because yes, a minus a square minus b square is equal to a plus b into a minus b. We used here this algebraic identity. Then we wrote the two factors for this expression p square minus q square. Understood this step, my children? Right. This implies 2a into p minus q is equal to minus d into, let us take common factor p minus q. P minus q into what will get p plus q, p plus q minus 1. Yes or no, my children? Right. Here p minus q gets cancelled. Then what will you get here? 2a is equal to minus d into p plus q minus 1. Understood this step, my children? 2a is equal to minus d into p plus q minus 1. Okay, my children? Right. Here I wrote the last step again here, my children. 2a is equal to minus d into p plus q minus 1. Okay, my children. Now let us transpose this term to LHS. Then we get 2a plus p plus q minus 1 into d is equal to 0. Understood this step, my children? We have transposed this term to LHS. Then we get plus p plus q minus 1 into d is equal to 0. Let us assume that this is equation 1. Okay, my children? Right. Now let us find the sum of p plus q terms of arithmetic progression. Sum of the first p plus q terms of the arithmetic progression is equal to sp plus q. What will get? P plus q by 2 into 2a plus n minus 1. N means here p plus q. P plus q minus 1 into d. Yes or no, my children? In the formula Sn is equal to n by 2 into 2a plus n minus 1 into d. In that formula, we have substituted p plus q. N is equal to p plus q. Then we get p plus q by 2 into 2a plus p plus q minus 1 into d. Okay, my children? Right. This is equal to p plus q by 2 into 0, because from the equation 1 we get 2a plus p plus q minus 1 into d, that value is 0. So from equation 1 that is equal to 0. Therefore the sum of the first p plus q terms of arithmetic progression is 0. Understood, my dear children? Right. Now come to the question number 11. 11th question. Sum of the first P, Q, R terms of an arithmetic progression are A, B and C respectively. Okay, my children, understood this step? Understood this sentence? Prove that A by P into Q minus R plus B by Q into R minus P plus C by R into P minus Q is equal to 0. Okay, my children, we have to prove this statement. Okay, my children. Right. As we have assumed, first term of the arithmetic progression is A and common difference is D for the previous questions. Here also let us assume. Okay, my children. Let us consider here. Let us take capital letter A, because already small letter A is given. Okay, my children. So capital letter A be the first term, and D be the common difference. D be the common difference of an arithmetic progression. Okay, my children, as we have assumed for the previous questions, here also let us assume that capital letter A be the first term and small letter D be the common difference of the arithmetic progression. Okay, my children. Then what is given here? Sum of the first P terms given SP. Here I am writing directly. SP is equal to, what is meant by SP? P by Q, P by 2 into 2A plus P minus 1 into D. Yes or no, my children? Similarly, this is equal to A. Let us consider this is a result to 1. SQ, sum of the first Q terms, Q by 2 into 2A plus Q minus 1 into D. This is equal to B. It is given that in the question itself. Okay, my children, understood this step. Similarly, SR, sum of the first R terms, R by 2 into 2A plus R minus 1 into D. This is equal to C. Okay, my children, understood these three steps. Now, let us take this LHS. Let us take LHS. LHS. A by P into Q minus R plus B by Q into R minus P plus C by R into P minus Q is equal to, let us substitute A value. What is A here? This one, P by 2. So P by 2 into 1 by P into Q minus R. Understood this first term, my children? P by 2 into 1 by P into Q minus R into 2A plus P minus 1 into D. Okay, my children, we are substituting A value plus B. What is B here? Q by 2. Q by 2 into 1 by Q, B by Q, 1 by Q into 2A plus Q minus 1 into D. Understood this is second term, my children? Plus C by R. What is C value here? R by 2. So R by 2 into 1 by R into, here R minus P. Here P minus Q into 2A plus R minus 1 into D. Understood this is third term, my children? Right. Now let us simplify here. P gets cancelled here, Q gets cancelled here, R gets cancelled. Then what will you get? 1 by 2 is common factor for from all these three terms we can take it out. 1 by 2. Q minus R into 2A plus P minus 1 into D plus, then what will you get here? 2A R minus P into 2A plus Q minus 1 into D. This is the second term. Plus 1 P minus Q into 2A plus r minus 1 into d. Understood this last term, my children? Right. Understood this step, my children? Right. Now let us simplify these terms. Okay, my children? Right. Here I wrote the last step again here. Okay, my children? Right. That is equal to 1 by 2 into, let us multiply, let us use the distributive property. Q minus R into 2A plus Q minus R into P minus 1 into D. By using the distributive property, we get these two terms. Similarly, here also use the distributive property. R minus P into 2A plus R minus P into Q minus 1 into D. Okay, my children. Similarly, for the last term, P minus Q into 2A plus P minus Q into R minus 1 into D. Understood this expansion, my children? By using the distributive property, we get these steps. Understood these steps, my children? Right. That is equal to 1 by 2 into, let us take 2A common from all these terms. What will get to Q minus R plus R minus P plus P minus Q into 2A. Okay, my children, here also 2A, here also 2A, here also 2A. From these three terms, if you take 2A common, we get Q minus R plus R minus P plus P minus Q. Understood this point, my children? Similarly, from the remaining terms, let us take D common. If you take D common, then what will you get here? Q minus R into P minus 1 plus R minus P into Q minus 1 plus P minus Q into R minus 1 into D. Okay, my children. From the remaining terms, I have taken D common factor. Here from the three terms, I have taken 2A. From the remaining three terms, I have taken D as common factors. Then we get this step. Okay, my children, understood this step? Right. That is equal to 1 by 2 into, here plus P minus P gets cancelled, plus Q minus Q gets cancelled, plus R minus R gets cancelled. So 0 into 2A plus, okay, my children. Now here let us use the distributive property. Here also distributive property, here also distributive property. Okay, my children, multiply PQ minus Q. Okay, my children, minus PR plus R. Then we got these four terms. Okay, my children. Similarly, multiply here. QR minus R minus PQ plus P. Understood these four terms, my children? By multiplying these two expressions, we get these four terms. Okay, my children. Similarly, PR minus P minus QR plus Q into D. Okay, my children. Then we got these four terms by multiplying these two expressions. Okay, my children. Right. That is equal to 1 by 2 into, here I am not writing this first term, 0 into 2A. What will you get? 0. So no need to write here this first term. Now let us simplify. Here plus PQ, here minus PQ. Here plus Q is there, minus Q. Here minus QR, minus PR, here plus PR is there. Here plus R, here minus R. Here plus QR, here minus QR, here plus P, here minus P. So what we get? 0 plus here 0 into D. Okay, my children, that is equal to finally what will get here? 0. That is equal to RHS. Hence proved. Understood this question, my children? Right. Now come to the question number 12. 12th question. The ratio of the sums of m and n terms of an arithmetic progression is m square is to n square. Show that the ratio of m and nth term is 2m minus 1 is to 2n minus 1. Understood this question, my children? Right. Here also let us assume that the first term of this arithmetic progression is a and common difference is d, because it is not given. Let us assume that a be the first term and d be the common difference Okay, my children, understood these two lines? Here we assumed that a be the first term and d be the common difference of the arithmetic progression, because it is not given directly. Okay, my children. Now what is given here? Given Sm is to Sn is equal to m square is to n square. So now my children, sum of the first m terms is to sum of the first n terms is equal to m square is to n square. So now my children, right, that is equal to Sm by Sn is equal to m square by n square. Ratios can be written as a fraction. Do you remember this point, my children? Right. Now Sm, let us write the formula. M by 2 into 2a plus m minus 1 into d by n by 2 into 2a plus n minus 1 into d is equal to m square by n square. Understood this step, my children? Here we used the formula sum of the first n terms of an arithmetic progression, where n is equal to m. Here n means same formula. Okay, my children, understood this one? Here 2 gets cancelled. Here m gets cancelled. Here n gets cancelled. Then what will you get? 2a plus m minus 1 into d by 2a plus n minus 1 into d is equal to m by n. Okay, my children, understood this step? Right. Now let us take cross multiplication. By cross multiplication, we get, directly I am multiplying here, 2an plus n into m minus 1 into d is equal to 2am plus m into n minus 1 into d. Okay, my children? Right. Let us bring this number this side and send this number that side. 2an minus 2am is equal to m into n minus 1 into d minus n into m minus 1 into d. Okay, my children, understood? All the a terms are written in LHS and all the d terms are written in RHS. Okay, my children? Right. Let us take common here. Minus 2a minus 2a. Then we get m minus n. Okay, my children? Right. Here let us take a d common factor. So mn minus m minus mn plus n into d. Here I simplified directly. I multiplied these two and I wrote here I multiplied these two minus n into n minus 1. Okay, my children, understood these terms? Right. Then m minus 1 gets cancelled. This implies minus 2a into m minus n is equal to, here also let us take minus common, m minus n into d. Okay, my children, here m minus n gets cancelled, minus minus gets cancelled. Then we get 2a is equal to d. Let us consider this is the result 1. 2a is equal to d. Understood this step, my children? Right. Now let us write the ratio of mth term and nth term. Okay, my children. Now Tm by Tn. It means mth term is to nth term. What is the mth term? A plus m minus 1 into d. Yes or no, my children? Here a plus n minus 1 into d. Because nth term of the arithmetic progression is equal to a plus n minus 1 into d. Okay, my children? Understood this step? Right. This is equal to a plus m minus 1 into 2a, because we have already found 2a is equal to d, by a plus n minus 1 into 2a from equation 1. From equation 1. Okay, my children, understood this step? Now let us take a common. A into 1 plus 2m minus 2 by a into 1 plus 2n minus 2. Understood this step, my children? After taking the 2a common, here we get numerator like this and we get denominator. Now let us strike out a. Then what will you get? 2m minus 1 by 2n minus 1. This is nothing but the required result. So hence proved. Understood, my children? Right. I'm sorry, my children. At the time of concepts, I have not discussed this point with you. Arithmetic mean. Okay, my children, before this exercise, I have not explained this point. Okay, my children, arithmetic mean. What is meant by arithmetic mean? Given two numbers a and b. Okay, my children, two numbers are given a and b. We can insert a number capital letter A between them, so that small letter a comma capital letter a comma b is an arithmetic progression. These three numbers form an arithmetic progression. Okay, my dear children, such a number capital letter A is called the arithmetic mean of the numbers A and B. Here we inserted a number capital letter A between these two given numbers. Then this number A is called arithmetic mean of the numbers A and B. Okay, my children, note that in this case we have A is equal to A plus B by 2. Okay, my children, this is the formula. Remember this formula, arithmetic mean formula, A plus B by 2. Arithmetic mean of two numbers is A plus B by 2. Okay, my children. We may also interpret the arithmetic mean between two numbers A and B as their average. Okay, my children. Both represent the same arithmetic mean or the average of the two numbers A and B. Both denote the same concept. Okay, my children, understood this point? For example, arithmetic mean of two numbers 4 and 16 is 10. Okay, my children, we have thus constructed an arithmetic progression for 10 and 16. These three numbers form arithmetic progression by inserting a number 10 between 4 and 16. Yes or no, my children? So this 10, the number 10 is said to be arithmetic mean of the numbers 4 and 16. Understood this point, my children? Right. More generally, given any two numbers A and B, we can insert as many numbers as we like between them. Okay, my children, such that resulting sequence is an arithmetic progression. Not only a single number between the two numbers, we can insert as many numbers as we like between the two numbers. Understood this point, my children? So that the resulting sequence is an arithmetic progression. Come to this point, let a1, a2, a3, a4 and so on, an be n numbers between a and b such that a, capital letter a1, a2, a3, a4 and so on, an, b is an arithmetic progression. Between these two numbers a and b, we have inserted how many numbers were inserted, my dear children? N numbers were inserted between the numbers A and B. Okay, my dear children. So therefore, AN is equal to A plus N into B minus A by N plus 1. By using this formula, we can insert as many numbers as you wish between the given numbers. Understood this point, my dear children? Right. Now we solve the questions based on the concept of arithmetic mean in this exercise 9.2. Okay, my children. In the next class we discuss the questions based on the point arithmetic mean. Okay, my children. In the meantime, please go through this definition of arithmetic mean. Go through these points. Read well, my dear children, and understand this point well. Okay, my children, right.